Sample size needed for estimating the population proportion. The sample size required to obtain a 1 minus alpha times 100% confidence interval for P with a margin of error E is given by the following. N, which is equal to the point estimate times 1 minus the point estimate times the critical Z value over the margin of error squared. And what you would do is you would rounding up to the next integer where the point estimate is a prior estimate of P. So when it comes to the sample size, because you're dealing with either like a person or an object, you have to round up regardless. Now, if the prior estimate of P is unavailable, then you would use this formula. N is equal to 0.25 times the critical Z value divided by the margin of error squared. And again, rounding up to the next integer. The margin of error should always be expressed as a decimal when using these formulas. Now let's take a look at an example. Okay, determining the sample size. An economist wants to know if the proportion of the U.S. population who commutes to work via carpooling is on the rise. What size sample should be obtained if the economist wants an estimate with 2 percentage points of the true proportion with 90% confidence? So for part A, it says, assume that the economist uses the estimate of 10% obtained from the American Community Survey. Now, the first thing we need to do is we need to determine what is the critical Z value. Now, we need to determine with the 90% level of confidence. Now, remember that alpha is equal to 100% minus 90%, which is equal to 10%, which gives us 0.10. Now, to find the critical value, or the Z value, is alpha divided by 2. Well, alpha is 0.10. Divided by 2 gives us 0.05. Now, remember, this area, 0.05, is to the right of the critical Z value. In order to get 1.645, what we would have to do is the following. We want to find the area that's to the left, meaning what is 1 minus 0.05? Well, that gives us 0.9500. We want to look on our table of Z-scores, okay, and we're looking for 0.9500. So if you take a look here, these two numbers are both in between 0.9500. So that means we have a critical value of 1.64 and a critical value of 1.65. So if we take 1.64 and add 1.65 and then divide that by 2, that gives us a critical Z value of 1.645. So therefore, that's why we're getting 1.645 as our critical Z value. Okay, now that we have our critical Z value, now we need to determine what is the point estimate. Well, we can see that in our question, again, here is our critical Z value. We can see that 10% is the estimate. So therefore, the point estimate of 10% as a decimal is 0.10. Okay, and then what is the margin of error? Well, if we go back to the question, it says that the estimate is within 2 percentage points. So therefore, the margin of error is 2%, which is equal to 0.02. Okay, so now that we know that, now we're going to plug it into our formula. Now remember, the sample size N is taking the point estimate, right? And so what is our point estimate? Well, we determined that our point estimate in our problem is 0.10. So it's 0.10 times 1 minus 0.10. We found the critical value to be 1.645. And then we're dividing it by the margin of error, which is 0.02. Now let's use a calculator to then multiply. So we have 0.10 times 1 minus 0.10, and then close the parentheses, and then parentheses, we're taking the numerator, which is 1.645, dividing it by 0.02, and then we're going to square that parenthesis, or that quantity, and that gives us 608.8556. So what we want to do is, when we round that to one decimal place, we get 608.9. Now keep in mind that since it's a sample size, 0.9 is considered a person who commutes. So we round up for sample sizes, so therefore we get 609. Rounding this value up to 609, so the economist must survey 609 randomly selected residents of the United States. Okay, now let's move on to part B. Now, assume the economist does not use any prior estimates. So if that is the case, we're still going to use the same Z critical value because it's still a level of 90%. So we know, again, that our critical value is 1.645. But now we know that the P, or the point estimate, is unknown. So if it is unknown, then we need to use this formula here, which is N times equals 0.25 times the critical value of Z over E squared. Now again, we also know that the value of the margin of error is 0.02. Okay, so now what we're going to do is we're going to plug it into our formula. So we know that 0.025 multiplied by 1.645, which is the critical Z value, divided by the margin of error squared. Let's go ahead and plug that into our calculator. So we have 0.25, multiply that by 1.645, divided by the margin of error 0.02, and then we need to square that, and that gives us 1691.2. Okay, we can round that to 0.3, right? And therefore, we need to round up. And again, 0.3 is considered a person who commutes. So we round up for the sample size to get 1,692. So rounding this value up to 1,692, so the economist must survey 1,692 randomly selected residents of the United States. So the effect of not having a prior estimate of P is that the sample size more than doubled, because having the prior estimate of 0.10 gave us 609. When we didn't have the prior estimate, it doubled.